Yeah, I'm good. Yeah.
All right. Good afternoon, everybody. Thank you for being here. Our project is the multi-purpose camera. And its purpose is to provide the consumer with a inexpensive device for which they could stream video to their phone. And they could use that for a plethora of situations, whether it be a baby monitor to make sure their baby isn't in some kind of duress while they're in another room, to a dash cam on your car, so to make sure to protect yourself in case of like car collisions or like through that you didn't cause any crashes or anything like that, to anything else that you want to do with it. And compared to competitors like the Ring doorbell, for example, when you set it up, you put it next to your door and it's stuck there. And now what do you do with it? You just leave it there, right? After a while, you're probably not going to need it, especially if you move to another house. Unlike the Ring doorbell, you could just pick ours up and move it with you, or you could use any other device that has a camera and you could link it to our app and use it that way. On top of that, things like Ring doorbell, since they have they make deals with the local police departments where if there's some kind of altercation or criminal activity, they can legally take your the video from your Ring doorbell and give it to the police. Some people might find that as a privacy concern, but with us, you don't have to worry about that. You can do illegal stuff. But besides that, I'm gonna pass it to Justin to continue our demo.
All right, thanks, Tim. So the first thing you'll see when you download the app is the homepage. So as a new user, you don't really have an account at the moment. So you're gonna sign in. You're gonna put your username. So Jim Smith. I'll do Jim Smith at gmail.com. And then put in your password. So for the password, you need at least 8 characters, 1 special character, an uppercase, and a lowercase. So looking. So, and then your account is made. So the first thing you'll see is the live stream, which is the view page, and the libraries are the recording. And to prove that you're actually on your account, you would go onto the top, or you can go to your accounts page and it'll show over there, and I'll pass it on to Joanne.
Okay, so I'm going to log in using one of our demo accounts that we already have set up. It has files in there already. So you're just going to log in using your normal stuff. As you can see, we already have a couple streams on there already. So on our views and our libraries. And then on the side here, you can go into our menu and then view all of the settings as well. And then I'm going to pass this on to Nick to do some notifications. I have this on Do Not Disturb.
Oh, you have it on Do Not Disturb.
Yeah. But there's
Oh, yeah. So another interesting feature is the notifications. So when you sign in, it'll give you a notification that says you successfully signed in. If you log out and then you hit forgot password, it'll give you a notification that says forgot your password. And it'll give you notifications for all kinds of things, like when you start streaming, when you record a video. And that can also act as a security system, and you'll know if somebody's doing something on your account without you knowing. So with that, I'm gonna hand it over to Sid. Oh, you might have to log back in. Get the account. Sure.
So for this part, we're going to demonstrate our live streams. We have it set up already. So once we get that running, we can see. Oh,
So we're gonna start a stream from one of our cameras that we've set up over here. And
Nick is actually gonna put that. Say like you're doing a doorbell cam. You can actually put your device wherever you want to put it. So say like at the door since the door cam.
And
Are you actually?
And there we go.
Yeah.
Once you set that up, about 10 seconds or so later, you'll start to see the stream appear. And we can then watch and see people moving around on the camera. The reason for the 10-second delay is that we're using an HLS stream, which if we ever decided to implement like an app for Apple devices or iPhones, the only streaming type that they support is HLS. So it's sort of future proofing for that. And with that, I think we can go back to here. And yeah, you can have multiple streams. If you have a stream for, say, a device you previously set up, but then you like unplug it or something, you'll see that the stream is offline. And if you stop the stream as well, it should stop showing up. But I think we'll leave it on for now. And with that, I'll pass it to Kata to demo some other recording features.
Okay, for the recording, we just first we need to get into the device you want to record. Okay, so by tapping the item in the wrist, we can actually expand the live streaming. Then next, we're gonna click the three dots at the top. Then we have like some pop-up options there. Here we have like a share and the recording option. Here we want to do the recording, so we're gonna tap the recording. Yellow means buffering. Red is recording, so we're gonna wait for the red to come out. And then there's also like a 10 seconds delay in the recording. So as you can see, it turned out to be the red. So now it's recording. And I think it's taking recording right now on the server side, not the phone side. And then it also takes, we also need to record more than 10 seconds of the recording. Otherwise, server won't take it as recording because it's maybe like a user places a mistake or like just to avoid those system errors, we're gonna we implement a feature. And while we're okay, so here we go. We also have like a refresh button. So just to check the recording status, we're gonna do the refresh, but you might think right.
Check out the.
Yeah, this for some reason.
Oh, my laptop died. I'm sorry.
Okay, I think I can record from the phone and
You want me to put a phone camera in there and then we can try the recording?
sure, thank you.
Okay.
Okay, meanwhile, I think I can show the
Yeah, the left-hand side.
Okay, so first I would like to show you how to add cameras to your phone. What we can do is we can take cameras from multiple phones. And if you have the other phone's camera currently recording, then our device will try to stream from it. So we already have a camera set up, and then later we can show you how to set up the actual camera. But first we're going to connect it to our phone. What we're going to do is we're going to, we can click the share button and then enter the security code. And then we input the code and we should have a new camera. And so now what we actually have to do is we have to set it so the phone is recording. It doesn't record all the time. And we can click on our camera now and it should pop up soon. There we go. And then if you would like to leave the streaming page.
Yeah.
And so now it should stop working. So like normally, so it's not going to work all the time, like no matter, like the camera won't be recording all the time, but it can like automatically pop up when the camera is recording.
I can show the recording part.
Okay, now we want to continue the camera.
Stop the recording. I think I can, yeah. Okay, for the recording, I think I can show the recording first. First we're gonna just like I did before, I get into the, oh, I think it's already recording, so I think we can just stop the recording for now. I think it recorded the previous footage. Then I also have to wait for the same amount of time you recorded. Okay, it came out. Okay, I think it's there. Yeah, okay. So. Just to explain, this is the list view of the videos you have taken it. Those top two, I think top one is the one we took before this meeting, and the last two is the ones we took in this meeting. Okay, let's check one of those out. Okay, by clicking the one of those video, you can get into the detail view, and by pressing the play, we can actually play the video. Okay. Also, we have a little like
A lot choppier on Zoom than it is on the phone.
Yeah, it's a lot smoother. on
yeah,
the phone,
okay,
but-
it's very smooth. Yeah, so also we can have like a skip and scroll, like a rewind and stuff. Yes, that's the also we have the refresh button. If there's like a new stream coming up or like a stream has ended, we can also by pressing the refresh button at the top, we can refresh the library, then have new video comes up here.
And then I would like to show how to actually share your camera on the phone. So what we first want to do is log into a new account. How do I get to the app? Because whenever you're on an account, you can only like set up your camera once. So I have to make a unique email because it doesn't allow multiple emails. Okay. Okay, and so now what we can do is we can create the plus button, add the camera name, and then click the phone button. And so now our server accepted it as a new camera. And so if we look at our list, we can see that we have our own camera phone. If you want to click the share button, that's the code that we have. And if you want the video to start playing, you can click, oh, actually, let me do it still a little slower for you. So if you're on the main page, you look to the right of that tab, you see a little camera button. If you click that button, you will start recording. And now the camera is now running and it displays it. Okay. Is that it?
Okay, also we also have like I said that we can also have as many as devices as we want. We have like a pre-configured 2 more devices. So I think we can have 2 more devices in this phone. Then I think we can finish this meeting. So I'm going to share one of the camera in my phone. Then share it to here. I'm going to get the code. I'm going to type in here. 6, 8. Let me type in the 6, 8, 6, 5. You're going to type the connect. Then barabim baraboom. Here we can see the Sid's mother.
That's my mom.
Live streaming from
Streaming from Brooklyn, New York.
that's amazing. Okay.
So yeah, that wraps up our demo. Thank you for your time. Thank you for listening, and we'll take any questions.
You know if it's being recorded? Oh, nothing I would have done. Amazing. What was the most challenging aspect of working on a project like this?
It would probably have to be the server people.
Okay, so server was the most toughest component in this project, I think, because like we had to connect multiple components into the server. They have the live streaming from the device to device. So that was the most difficult part. Also, like we have we configured many accounts, then so that like each account can cooperate each other. Then like share devices. then share live stream each other so that we can use those in we can like share those streams among friends, family, then use it as baby monitors or the other use cases. I think that was the hardest part in a group.
You guys use AWS, right?
Yes.
What kind of aspects did you use from AWS?
So for the from the AWS, we combined multiple features from the AWS. One biggest component is, I think I would say, like a serverless server called Lambda. So now we don't have server in this one, but we have the serverless server which runs on request. Then that like process our like request from phone. Then like can perform our MPC components. Also, we have for the live streaming, we use service called IVS, which is interactive video services from Amazon, which enabled us to perform the live streaming. And we also used things called the media converter and event bridges to have live recording and live streaming possible.
Yeah, any questions?
So you mentioned concern of the data privacy issues with Ring doorbell storing your recordings. Where are these recordings stored?
Oh, you mean on the Ring doorbell? You're just like where the Ring doorbell saves their recordings?
I know that they store theirs in the cloud. I'm saying, where do you guys store your?
Or where do we store ours? Oh.
Yeah, we store it in an Amazon S3 database, and you need an authorization token that you only get from your account to view them. So
Is it encrypted at rest, or is there any type of encryption, or is it kind of just like, you know?
I mean,
Since you guys mentioned the security and privacy concerns of using Ring doorbell, what's the difference between trusting Ring with your video and trusting you guys?
we have no legal obligation.
Yeah. Also, the difference is with Ring doorbells, it's a contractual agreement with the local law enforcement, so it takes you out of the equation entirely. That's why I made the mention of it, because like you still have the sense of autonomy when you own the device yourself.
But if you guys own the recordings, they can still see the recordings if the FBI comes to you with the warrant.
I see what you're saying.
That has never happened. That's never happened.
Well, if they already have a warrant, they would already have.
Right.
Well, not if the user has. Also depends, if you have good lawyers, even the warrant.
Although
They just deny the FBI. They just go, Apple doesn't hold the key.
Yeah.
Keys are on the device, that's the whole one. No, we're gonna bring it up. It's good.
I believe what's meant to help, but access will not.
But it comes under First Amendment, and you're like also, you know, but please,
Yeah.
But on that point, you're,
I guess on the technical side. the
Yeah.
question, if you were to incorporate end-to-end encryption, what would be the difficulty given the technologies that you're using right now? Is it possible? Was it something that you considered in the design? That would be my question.
Okay.
I was gonna say, I mean, it's surely possible. If we were continuing with this project, that would be something that we could definitely do. There's libraries that can do that, or we could do it ourselves by making a cipher and then doing the XOR to encrypt the binary string and to send that over. But yeah, we had bigger fish to fry than worrying. We just wanted to make sure it worked, and we knew there wouldn't be any like, oh, wasn't the database also?
Oh, don't.
Oh, okay.
Yeah.
Our database was hacked.
Oh, interesting. Can you tell us about that or,
I think he had the database key in
In the
GitHub,
repos
but then we
directly,
later
yeah,
took it
that's
away,
right.
so it is more secure now.
yeah, no, that's interesting. That's not the first time that's happened in a capstone class. But it sounds like you were able to recover everything, so that's good. A couple semesters ago in the ISFP capstone, a student put their key, their like API key in the code on GitHub, and then someone just basically locked their account and asked for Bitcoin.
That's what happened to us.
Yeah,
That's what
yeah,
happened.
yeah, so. Yeah, always have back.
Yeah, talking about the encryption, I think a lot of the time we spent was on the sockets. So that's why it would be hard to add that type of feature because a lot of our workload was getting those, like the amount of sockets we needed to end already, the sockets to work.
Okay, thank you. We have to move to the next project. So. So the next project is the competition. So,
I mean.
Should have been set up before. For the. We're not having them stacked up on each other. Yeah.
Which case would be a benefit.
So projects at the beginning, not everyone knows exactly what the projects are about, okay?
1 moment. All right. So you should be able to just lounge. Only these types of advertisements. All right, just where is advertisements now? Who doesn't have advertisements? They already sell their data. Opening this one. Got it. Exactly. All right, let's see. How do we do this? All right, good luck.
All right, guys, we are the vehicle collision device. So basically, just a quick rundown, what this device is it's you put this on your car, on the hood of your car. If this were to go into an actual car, we would have Velcro on it. You just put it in. It's got 2 modes. You can either run it on battery or you can run it on your car's power with a little cable in it. And what it does is it connects to your phone, Android or iOS. And when it detects a crash, it will send that signal to your phone, and your phone will automatically call emergency services and text a couple people in your contacts your location of where the crash occurred, and just a quick message saying, hey, I've been in a car crash, the car crash has been detected, and it will pop up. You can cancel it. So it will give you 10 seconds from when this device detects that you got into a car crash to actually calling emergency services where you guys can cancel it. And very quickly, I do want to go over 2 things that might come to your mind when you think about this device. One is, well, Apple has a device, something like this built into all your phones. And in the US, that's 6% of the phone market. So a lot of people have Apple devices, and it already does that. But the fact is that the difference between this and an Apple device is you bring your phone around. This should be in your car at all times. Just strapped there. You shouldn't have to think about it. And so what happens with the Apple is you go on a roller coaster or something, it goes off. So a lot of people actually turn off that feature because they don't want to deal with this. Another thing is that with this device, all right, sorry. I'll go to Evan to talk more about the device.
Okay. So we have a 3D printed case to protect the hardware. And that's this whole thing here.
And on the slides, on the right, you can see sort of on the left, you can see sort of an exploded view of the case. This red part here is sort of the main body of the case where most of the hardware is. This little blue thing that holds a 9-volt battery. And this purple thing here, that's a clip for the accelerometer that we used because most of the components are padded with foam, but we don't want to pad the accelerometer too much because that could dampen the results that we're getting. And this green thing here is just the lid. And if you can see it on the lid, there's like a big hole. That's because there's a button inside that we have to press to turn on the device, and that just gives this little thing to put our finger into. And on the right, you can see like sort of how they fit together, except for the lid. And then there's holes here, so they just screw together. And this is what it actually looks like inside. So in the back here, behind all those wires, that's where the Arduino and the Bluetooth module are. And this little black thing right here, that's the button that we have to turn it on. And there's this plug up here that goes into the battery. Yep. And so this way, to change the battery, all we have to do is take the lid off and swap the battery out. And this little red thing here, that's the accelerometer, and that's just the way it clips in. So now Arif's going to talk about how the device actually works.
All right, so this is the data flow of our project. So looking at the left side, we have the microcontroller device containing the Arduino, the accelerometer, as well as the Bluetooth LE shield. The device connects to the vehicle detection apps using Bluetooth LE, and it's low energy, so it's compatible for both our iOS and our Android app. The apps make use of your phone's storage to store and retrieve emergency contacts. So when a user inputs contacts and then closes the app, the contacts will still be saved to the phone. When the apps are notified of a collision, and the user opts not to cancel the detection, the app will make use of its respective operating system to call emergency services as well as text the emergency contacts. So the accidents are detected using the accelerometer, of course. The accelerometer gets data from 3 directions, X, Y, and Z. If any of those readings reach the threshold of 10 Gs, it will send a signal over the Bluetooth low energy using a GAT characteristic, and it'll essentially notify the app that the user has been in an accident. So more about the Bluetooth. The device has a connectivity range of about 10 meters. So any mobile app outside of this range will not be able to discover the device. It can only connect to one app at a time. So if the device is in connected mode, it will not be able to be discoverable to other apps. And an important note on that, if a user fails to connect the connected device in 30 seconds, the device will enter a power down state to conserve battery power, of course. And the mode LED on the device will be powered off, which tells our users that the device is powered off. And the way to boot it up would be to press the button, like Evan said. And it's kind of hard to see, but the mode LED will start flashing red. The mode LED will start flashing red. It's kind of hard to see. And that tells our users that the device is on, it's ready to connect. And it'll give our users another 30 seconds to connect their phone to the device. And that's all I had to say about the functionality of the device. I'll hand it off to Brad to introduce the Android app.
Sorry.
All right, so I'm just going to explain kind of the front-facing aspect of our Android app. So you can see we have 3 components. At the top, we have our Bluetooth connection status. Right now, it reads not connected because I haven't connected it yet. But there's a prompt right under saying tap here to attempt a connection. So we're going to try that later. Under that, we have our emergency contact list. This holds all the emergency contacts, and this, as Reeve said, is saved and retrieved in our app's internal storage. And then we have at the bottom just buttons for adding and deleting contacts. So we're gonna test adding a contact. So we'll test add Tamer and the test number. So you can see that the list is updated once you add it. So now I'm just gonna swipe out of the app and then reload it, and Tamer's name should still be there on load. So now just to delete a contact, we kind of have a little security measure where you have to type in the full name, so there's no like accidental deletions when you're using the app. So if you type in Tamer's name, hit delete, it should be clear from the screen. So now we're just gonna try to connect it. So you can see a prompt under not connected saying tap here to attempt connection. So I'm just gonna tap it. And it's scanning for the device, and now it's connected. So I'm gonna pass it off to Austin to kind of explain some of the other portions.
So as mentioned earlier, there's going to be an alert that pops up whenever the accelerometer detects a crash. So there's only one way to actually showcase that. And then take note, as it's driving, it's not going off while it's driving. It only goes off when it hits the wall, aka detects a crash.
The phone.
So as you can see, it's detected a crash and it's coming up with the alert. So in this scenario, we're just going to say it's a false positive. I click cancel, goes away, doesn't call or text anyone. And then if I crash again, this time I'm going to let it count down from 10 to 0, just to showcase the calling and texting. And
So in this case, I'm emergency services set in the code because we didn't actually want to call 911,
Yeah.
but I'm getting the call.
obviously we can't call 911, but as you can see that calling is going off. And then if I go to the text I sent myself, you will see it comes up double because I texted myself, but here you can see, hello me, I have been in a serious crash, address, the address we are at located currently, and the coordinates just in case the address is not accurate, especially if you're on the road, not near a city or anything. And if you click on the address, it pulls it up to Google Maps. And then so what if you can't reach your phone to cancel it? What if there's a false positive? If your phone's in your bag or something, or it falls off the dashboard? If you can, one more time. I'm gonna try to say stop. And it stops. It also works with cancel as well. And yeah, those are the two commands. And then I'm gonna hand it off to Nate, right?
Yeah.
To start showing off the iOS portion.
So for the iOS application, we pretty much have the same functions, same functionalities. So down here, we have 3 tabs. The first one is the connection status. You can see that it's connected now. And if it's not connected, it'll appear, say device disconnected with a red font. And then we have the emergency contacts tab. Within here, we could add contacts. So here I'm gonna add a read. And if I swipe up, delete the swipe up the app, you're gonna have those 2 contacts there. And we also have the functionality to delete emergency contacts. So and then we have the prompt here asking us if we wanted to delete it or not. We can delete it. It's not going to be there anymore. And I'm just going to add it back. And we could also add it again, and we can see that we have a duplicated contact, just letting us know that we can add it again. And I'll be handing this to Don.
So
the iOS app works the same as the Android app. When you crash, the device gonna send the data that crash to the phone and gonna send a text message and call the emergency service. So right now you can see the device is connecting. So we try to run through the phone. As you can see, it's not detecting anything. We also have voice control, so I can test the voice control as well.
A crash has been detected. Please say or press cancel to halt emergency services.
And the thing disappeared. You crash it one more time, and this time I won't cancel and let it go, and you guys can see.
A crash has been detected. Please say or press cancel to halt emergency services.
So now it's fall off. So there's the call. And here's the text. So it will send your location as well here. And if you click on the location, it's gonna open the map. So in iOS, we use Twilio. Because there's some Apple privacy concerns, so we have to work around it with Twilio. So with Twilio, you can set the message in the calling as well. So it's very powerful. So like if you're actually like tracked and disabled and you cannot do anything, you can send like a free message for it. And it's gonna call 911 and it's they're gonna say the app gonna say everything for you without you touching your phone. So yeah, that's the iOS demo done.
That's it.
That's it. That's all.
We're open for any questions from here.
So you can set anything for the phone, say 911. You can type it in. You can. So if you pay for the Twilio service account, so we cannot pay it because it will go through like Twilio needs to verify a lot of documents for privacy concern and all. So yeah, we don't have time for that. But you can do it with Twilio.
So how does it, what about the areas track? If I'm at a red light, I get like little light better, but would it just call 911? So how would that?
So
Stop that?
that's the logic behind the voice control and the false positives, like with canceling it. So ideally, it won't go off. It'll only go off in like an actual like severe crash. But in case it does, you can either tap on it or use your voice to cancel it.
And so that's why we also set our threshold to 10 Gs because we were playing around with, what could be a minor fender bender. What are the Gs you're looking at? What are the Gs you're looking at when you're hitting somebody 30 miles an hour? That's when you want to call someone. So that's where we thought of the 10 G counter.
And this would go in the center of the car.
This would go on the dashboard.
How far do you think you are, like, let's say I get really annoyed from hitting speed bumps and getting false positives. Do you think you'd be able to like soon add the threshold to the UI? So I could like customize how much it goes off?
Yeah, we were actually talking about that initially, but just due to time constraints, we didn't have that added.
Wait, there's one more.
So many.
On the Android side of things, so do you guys use the built-in Bluetooth Low Energy API? Or do you guys use an external library? So I've had issues with the built-in.
We use the built-in.
You didn't run into any issues with that.
It was
We
hard
had-
at first.
Yeah, we had issues at first because with the parts we ordered, we didn't know Bluetooth LE was a thing. We thought it was just general Bluetooth. And then so once we discovered it, like, oh, Bluetooth LE is a thing, we have to look at this. It was pretty straightforward from there because the documentation is straightforward.
And on Android, is it still using that pre-recorded audio or is it just making the phone call to the person, to the emergency service?
It's just making a phone call.
Okay.
With Android, it's near impossible unless you use some like weird API you find on the internet. And we wanted to constrain ourselves to use mostly like just base Android APIs. So
But one concern I do have is that it is illegal to dial 911 through an automated system. It is.
Well, yeah, so
Alarm systems. It always has to be someone who dials emergency service.
yeah, so if this goes to production, right, we're gonna have our own think of it as a subscription service, but basically it will call a call center. And the call center will ask you if you're all right, and then they'll dial 911.
If you like think of like Life Alert, that's like an example of that.
And since it has the GPS in there, they can send the location as well.
You can sit as well.
Okay, we close to time. Thank you very much. Also for the last meeting, please your voice, but other than that, excellent. Thank you very much. Yeah.
I thought you
Yeah, so I don't think it's that. Also, sitting your front of parking lot, like, yeah, that was absolutely.
We do. Yeah.
Oh, yeah. That's it, anyone, just.
We're just waiting for the robot to load up, but the first thing we did was turn on the robot so that they can get ready to boot and turn on. But we're the RoboControl group. We designed a robot for our project, and the first thing I'd like to note is that I like to describe our robot as like a proof of concept. It's kind of like a scalable prototype, whereas if this was a bigger project, we'd be able to pick up more things with the arm and buy better batteries to control the life for longer. But the idea of our project is to create a moving robot that you can control from anywhere. Kevin's showing the robot right now on its track, and this robot can be controlled from anywhere in the country, outside of the country, anywhere where you have connection to control the robot. So let me make sure the robot comes up, and it does. And let me share my screen to the Zoom. Ian's coming. No. Shit. Yeah. No problem.
And that's awesome. Hey, you're on good.
Okay, let me just confirm. Yep, okay. All right, so now we're all set up with the website, and we'd like to start by talking about user options. What a user will do first when they come to the website. So you come to the home screen and you first see two options. You have the left side, which is the control interface for the robot, the right side, which is the about page. So let's start with the right side, since we're pretending we're a new user and we've never touched the robot before. Okay, so Cindy, I believe you're on that about page. Yes.
All right, so at the top of the about page, the first thing that the user will see is how to get started on using the robot and how to get connected, and just basic control instructions for moving the robot and controlling it. As you scroll down, you can see other descriptions for the robot, such as the program workflow and how the website and the robot connects and what programming languages we use for this project. As I go down, this just describes the robot and how the robot connects with the server and the website, and next the server and how that plays into the role, and also the website and how that connects to the robot as well.
Thank you. So now that we know how to control the robot, we've gotten some instructions, got some information. Let's go back to the control page so we can start actually controlling the robot. On the control page, you can see two images here. And Ed will talk about the video processing for that.
Yeah, so you can see two video feeds on our website. They're coming from the same camera on the robot being run through a server and finally back to our website. And what's happening on the left side is color detection software that we're going to explain a little bit more later. And the robot is using that to work autonomously and run through our track here.
Thanks, Ed. So now the next step we're going to talk about is the password system. Peng will be taking over that.
From the point of view of a user, after a user sign up, his information will be saved in our backend server built by Express framework. And their password will be hashed separately in the backend server. And then in this case, we'll use the default password. And if the user enter wrong password, it will give information about that if you're using for one. And also users. And after login, the system will generate a position and for the current user in the queue. And this will help us to keep robot from multiple controls. And then my partner Olivia will introduce the control panel.
So Olivia, here's the either you can start controlling the robot.
So the way we've set up our, we wanted to be able to do this from like a touch screen, like a phone or tablet, as well as a computer, is that each of these buttons for the tread, the arm, the claw, and the camera can be used just by clicking on the button on the website. So this is forward. Backwards, left, right. And they can also be controlled by pressing the button on the actual computer because that's easier to do on for more work. You can also do control of the arm, so you can raise the arm and lower it, open and shut the claw. Bring the elbow up and down. And bring the actual arm up and down. The last thing we can do is control the camera, so the camera can go up and the camera can go back down.
So I'm just going to resize this so we can see both at the same time, just for moving the camera. As you can see, the camera can move up and down. There we go. And responds on the screen. So now, since we went over controls, I'll go to Anubhav to talk about the color detection. Once I lower, yeah.
All right, so for our RoboControl, we implemented color detection and image processing using our using Python's open computer vision libraries. And as it sort of suggests that we can use RoboControl's camera to just detect colors that as we see fit. And this sort of has a plethora of use cases, but for our purposes, we use color detection and image processing for autonomous movement.
And so with that color detection, Kevin can talk more about the autonomous pathway.
Okay, so for autonomous movement, you use the OpenCV package that Bob talked about, the color detection, or identify what we call contours. So we start from the most strict sense, which is the two contours here, but it also manages the same contour and no contour system. So with two contours, it does its best to find the middle position between the two colors that I see on the screen. You see that the fluctuation of the code for the left contour and the right contour, that happens because as The RGB values are measured within a range, so something is within those range, you'll identify that number. Maybe the other comments, please. Well, identify, and move, and look around, and try to find, little point. That whirring you're hearing is the motors not responding, because they're just too weak. But overall, if you go further along, you can see the robot is actually making slight small adjustment. So it's the end. And once it hits the end, there's usually some counters to see where okay, let's move backwards. If we see that kind of.
I'd like to take some time here to talk about like that whirring noise you heard, the difficulties of using hardware with projects like this. So these motors are far from perfect. They have an open gearbox, which allows for debris and air to get caught within that. This will cause the gears misaligning, and have misaligning means that they're not going to move the shaft of the gear or the motor. So this causes for the motors to slip. It causes for more power needed to be able to run the motors, and to do slow turning, the motors need more power. So to do slow turning, you need a motor with higher torque, and that is one of the reasons why we put an extra battery pack on the robot. That extra battery pack allows for one extra battery to be used alongside the two that were already on there. This gives more power to the motors, which allows them to move the system. So now I'm going to give a little demonstration of the possibilities of the claw, because right now the claw is the small scale, but if we were to scale it up on a different level, we could have more use cases for it. So in this demo, I'm a programmer. I'm trying to get done all my work, and I throw my trash to the side, right? I don't want to get up, so I use my handy little robot to go and find the receipt, as you see on the screen there. And then I will move the robot over, use the claw to pick up the receipt, and then bring it over to the trash can. Wherever the trash. So there's a lot of possibilities for something like that. It's a simple system right now, but if you scale it up, there could be other use cases such as carrying equipment for a construction worker or something like that on the field. And using line tracking, it could be used to monitor a hallway or a system indoors somewhere or outdoors. So Antonio now is going to go over using the mobile application, website that we have available.
Right, so I have it up on my phone right here. It looks exactly the same as the regular desktop website. It's worth noting that I am not on Wi-Fi. So obviously you don't have to be on the same network as the robot. You can be anywhere in the world if you want to control this. And if you did have this at your house and it was there's a little choice.
Oh.
If you did have this at your house and you were using the bot, and it's maybe like a security feature, and you were out with your friends and you wanted to control it and see what was in a different room, you can use. Yeah, hold on. Yeah, let me just sign back in. Yeah, so again, if you were, let's say, out with your friends and you didn't have access to a desktop and you wanted to look around your house and see what was in maybe your kid's room or what the dog was up to, you can control it straight from your phone. As you can see, I'm controlling it just like you would from the desktop. I don't know where it is, so. Yeah.
Okay, and I think that's everything that we had to demonstrate.
The floor is open for questions.
I have 3
three questions, actually. You made quite a connection to servers, so are you running in the cloud or what? What's your kind of server state you guys?
No, it was a server at my house, personal server.
Okay. Second thing, you made a lot of mention about being able to use this anywhere. What technologies did that entail and what difficulties did you have to do it?
Right, so that was a challenging aspect, at first, because I had to do some research. I asked a couple of friends about what, like, we could use for this, and our group decided to go with WireGuard, which is VPN, like VPN thing used to connect this directly to a VPN server that you have, and that's what's running on my server at home, and that's what this is connected to. So as long as this is connected to Wi-Fi, it has a local connection to the server.
And my third question is, what are you using for video streaming? Are the other team use AWS's solution? Since you're not using AWS, what do you use?
So video streaming was a tough thing to tackle. We started out using WebSockets and only WebSockets, and that was good, but it wasn't perfect. There was a lot of lag. Sometimes video wasn't showing up, and we decided to end up going with using GStreamer, which is a UDP streaming command line interface that you can use to send commands from the robot to our server, and then we use Flask to send the video from the server to the website.
So in the autonomous mode, when the machines were not moving, that's completely due to the weak motors, right? Not the code.
It's primarily because of the motors themselves. If we had a bigger budget, we could hopefully get more robust market.
This was passed down to you by Professor Wayne.
So
Part of the problem is that there's, like, you can use it, right? As you can see, we're controlling it. The problem is it can really only move fast right now because it can't start up slow. So that means when it turns past the line. Before, when the gears weren't stripped, we could just move slowly to the right side. That's why you saw it working.
I was wondering, the camera was pointed really far down, and that made sense because you're like seeing with the two yellow lines. Did you think about moving the camera up and just like generally going towards the yellow?
we did. The issue with that was the fact that we're detecting colors within a range. So if any other, say, variant yellow existed, it would also detect that. We would have to put the nominal assessments on. So the lower we get, the more isolated. That being said, though, we can reduce that range to a very specific value. I think that if we didn't rely solely on, say, just a visual spectrum camera, we utilize something more like IR or something else, that would probably be utilize the combination of the two in order to affect a much narrower range, which to identify this.
As you can see in the video, we actually, like, you can tell it's on purpose because we actually 3D printed the camera mount. It had an original camera mount, but it was much too high. It was horizontal to the floor. So we needed to angle it down. So can you move the camera down? So when it goes down all the way, you can see that this angle here allows it to angle more towards the floor. And that's a custom 3D printed part along with the battery mount. Question. Have you ever seen the movie Wall? Yeah.
Eventually, we're getting there.
We're getting there. Yeah. That is the biggest problem with this design. It will not work in light conditions because of these physical aspects. That's why using something like a line tracking system might work better, but I don't know if I would.
You experiment with adding a link to it.
That's a good point. Yeah, that would.
I mean, it was a thought for later on. Yeah, but as it is now with the power draw and the batteries themselves, it's like one of our major concerns at the start was simply how much power was sustainable to it, which is why we try to move a lot of code to the server. The server can do all that heavy lifting in terms of image processing, development on board, identifying range of the pixels within the range. They can bring that numerical value for the board. So it's really just like a limitation of the hardware, but then again, hardware can just be up and being more robust. So feasibly, yes, I could be done.
Nuclear power plant.
We had a full fusion reactor.
So I actually have a real question, not a movie related question now. So we saw in the last couple demos where power was an issue. And in this demo, it clearly wasn't. Were there optimizations that you added to make the software work like lower power, or did you just prepare really well? Extra battery?
Originally, before the battery was added, and we were working on the autonomous code, we had to actually adjust the speed to the amount of power left in the battery. So as if you install fresh batteries, you move at a lower speed, that would give you reasonable performance. But then as the power draw started to drain the batteries, you would actually have to adjust the speeds a bit higher. Because the motors at that low power would not be able to turn. So you have to force more power into the motors and to the more force to turn. So as a result, like, the third battery really solved a lot of the issue.
If we were, like, if we had more time to work on this, we could use a fourth battery to and wire it up properly so that could increase the amount of time.
Definitely has like a lot of perspective. We got Boston Dynamics, their robot. They're like permanently hooked up to like a power source. So as a result, it's like, oh, there's probably a reason for that. We literally had to figure that out.
Yeah. Yeah.
I understand like the third battery obviously helps the motors, but don't you think the added weight also puts stress on the motor?
Yeah.
But it's a trade-off because right now, like that increases the voltages. These motors run at 12 volts. So since the motors run at 12 volts, it was getting, but each of these batteries is 3.7 volts. So it's getting 7.4 volts. So with the increase, with the extra battery, that increased that to about 14 some volts, which, or no, not 40. It was like 14 11 volts. What? 11 volts is 3.7 volt. That. Thank you. So about 11 volts, which helps with the
Don't remember, is the robot powered by the Raspberry Pi embedded system? Like, what is making all of the motors function?
Raspberry Pi.
Raspberry Pi.
Yeah, there's a hat on top of the Raspberry Pi that distributes the motor and servo. There's 5 servos on this, one for the shoulder, elbow, we call it, which is a joint, arm, and then the camera. And then there's one more that turns on that we didn't utilize.
Are you using the Raspberry Pi OS, or are you using another version of Linux to power it?
If I could restart it, I would use Ubuntu. Well, I'm not sure about Ubuntu, but I'm using a what do you call it? End of life distribution for Raspberry Pi, because that's what it used to use, which is where we got this robot from. So we started out with that. We used the error code and made sure it worked. But now that I know the code, we know the code in and out, so we could go to the different operating system.
Yeah, that makes sense. Yeah, when you're working with like legacy code.
Legacy, that was the word.
Yeah. Yeah.
Okay, are the batteries good or like what is the power density? Like, if you know.
I think these are 2200 milliamp hours, which will allow it to draw 1 amp per, and they're wired in series, which just increases voltage, not the amperage. So it's 2200 milliamp hours, which will allow it to draw 2.2 amps for 1 hour, which sounds like a long time, and it probably is, but they're not always perfect as well.
We have like 4 sets of backup batteries.
Yeah.
Because it's just drawing so much power and charging it takes so long. So through this whole like testing process, we would test it for like 10, 15 minutes, an hour, we fall down, we would wait like 45 minutes.
It was longer.
very much. Thanks everyone for the demos today. They were very nice. And we appreciate your hard work for the semester. Remember, you need to fill out the self-evaluation for your team members. I recall the deadline maybe it's tonight.
It's a couple days, but I know that I made the assignment tonight.
Okay,
I
I
shouldn't
think
be
if you
thinking
go on
about
with this tonight, this not tonight, but at least you already now know your team members. Oh, yeah, May 7th, I think. What? And then you have to. Yeah.
All the documents that were due tonight.
Yeah, okay, May 7th. That May 7th, yeah, on the May 7th, we have to finish your I postponed it because you didn't have. Okay. Okay, everyone, one last thing, finish the document by May 7th. Send evaluation as soon as possible for your team, okay? After that, you are hopefully, congratulations.
Congratulations. Yeah, welcome. Are you in my section next semester?
Sorry.